Hello, guys. My name is Michał Jankowski. I would like to welcome you on my today's presentation about the serverless. Are you ready for a revolution? Just briefly about me. I'm a technical architect, team leader that's working for Objectivity. Together with that, I'm Microsoft Azure MVP. In my free time, I'm travel a lot. I'm trying to write some blog posts. I'm trying to be better on the Twitter. It's a challenge for me. And I have some project on open source project on GitHub. Today, I would like to exchange with you my knowledge about the serverless. This is something that I would like to. I'm focusing, and I would like to focus in next month, next year, and I would like to share with you about idea how this approach should change our mindset for working with application, with designing the application. How we should do it? First of all, I would like to show you and talk you briefly about the serverless. Short introduction to have the common meaning of this term. Then I will talk about a revolution. I will show you how I think that this approach should change our mindset. Then I will focus on Azure. I will go just briefly through the services that are available on that platform. Of course, there are similar services on Amazon Cloud and also Google Cloud, but for you, I think the most important thing is the idea. And at the end, I would like to show you a real case scenario, something that you can see how we can use these components to evolve the solution, to build something from prototype to production-ready solution. And short question, is anybody here is using serverless in their projects? Just raise your hands. That's perfect, nobody. I know, one person. And are you using some clouds, maybe Azure? Okay. Amazon? Still not much. Google? Some exotic one? Okay, let's go. So let's start from serverless. And when I'm talking about the serverless, I think this is my resume. If I think about this table, this is the history of my life. When I started my first job, I was working for Nokia Siemens Networks, and then I get under my responsibility 2 servers. Those 2 servers were standing under my desk. And for young software engineer, it was very important to have not only the keyboard, because I thought after the studies that when I be developing application, for me, the most important thing is my head, my keyboard, and knowledge of software language. And quite fast, I get know that I need to have screwdriver to open the case of the computer, because something happened with the hard drive, something happened with operation memory. And I was a bit shocked. Together with that, I was very happy that I had those servers under my desk. I feel the power of the company. In the morning, when everybody was coming to the office, I hit the heat. I feel the heat of the computer. I heard the fans of it. But together of software development, I need to know how to set up the network, how to change the hardware, how to update operating system. Think about when you are working in the bank. Then, even small software update needs a lot of approvals. Then somebody in a company decided that they will take my servers and move to the server room. So we moved to infrastructure after service. I was happy because I didn't need to take care about networks. They give me like a virtual machine. Truly, they moved my cases there. Still, I left my screwdriver because I tried to believe him the day that will handle my server, but in the server rooms, in most cases, you don't have access to go there. So I know that with the screwdriver, with the hammer, I will be able to open the doors if I need to access to my computer. Then there was a platform as a service. Another layer we just thrown to the trash. So we get only the application layer with the data. And finally, there is a serverless. It is like a magic. We are talking about something so small, like a function, that if we follow the contract, Our vendor will allow us to run solution. We don't need to think about the network. We don't need to think about operating system, about the hardware. We are focusing on development. We can show this table in a bit different way. This is also very good, showing how our approach for working with software evolve. On the left side of this table, we have infrastructure as a service. So we can see that we are scaling the whole VM. Our abstraction level is a hardware. When we are deploying something to virtual machine, we are thinking that this kind of solution will almost live forever. Maybe not forever, but this is sometimes it's very difficult to update it. So we are thinking about the month. And if we are checking our responsibility, it means that we are responsible for application, dependencies, runtime, operating system. You can see how our approach evolved to serverless. Then, if we think about scaling, this is function. This is so simple. Sometimes it is 20 lines of code that can run and do a lot of things. Then, if we think about an abstraction, it is runtime. If we are thinking about the unit of thing that we are responsible for that, it is only code, nothing more. And the whole lifetime is something below minutes. Our function can very easily run, start, and when we don't need them, they will be just put to the trash. And what is the most important thing for me, I'm only responsible for the function. As a software developer, I know how to code, and I hope I can do it correctly. So I would like to be responsible only for this one thing. If we think about the serverless, what is something characteristic for this approach? Maybe the name is not best one, because with the term serverless, you can think there is no servers under the hood. There are the servers, but we don't need to take care with those servers. Somebody else, our vendors, is managing that. We just need to follow the contract that is provided by those vendors. Together with that, serverless term means that we are running our functions, so maybe not only functions, but in most cases when we are talking about the serverless, we are thinking about the functions. There are other products, and I will mention about that. But we are running those functions based on the events. It can be HTTP trigger, it can be time trigger, maybe some file will change on the blob, and this our function runs only as many times as those events exist or executed. This is great because it can, in theory, scale up very fast, rapidly, almost without limits. I know this is stories, platforms have some limitation, but together with that, it is a great thing that we are paying for that solution in a bit different way. There is something called like micro-billing. We are paying only for the time of execution, even not the time, the numbers of execution of our functions. And it means that we can provide the solution that is ready for very small traffic and can sustain, for example, Black Friday, when everybody will be hitting our backend. Together with that, we need to remember that the second side of the endpoint is our wallet. So if somebody will try to attack our solution and do some DDoS attack, it is targeted on our wallet because our solution will scale up very fast and handle this traffic. So we should protect our application against that. This is, let's say, technical stuff. If I think about way of working, I love it because it means for me I'm more productive. I can focus on development. Because I'm focusing on development, I can think about providing business value to my customers. So I am focusing on features. Then when I'm focusing on features, I can hit the market faster. And I think this is the most important thing about the service approach. We can put our product on market faster than our competitors. But you can hear that I'm saying a lot of good things. But when you are trying to play with this technology, the grass is not so green always. When I think about running the solution, it's great that it can very easily scale up. When there is no traffic on our on our solution, we sometimes have some problem with time of starting. So vendors will just put to the trash the environment, and we need to run again environment when we'll get another traffic. Together with that, when we're thinking about the serverless, everybody is saying that it is stateless. It should be stateless. It means that every execution of the function should give us the same result, and it can cost us a lot to do such a solution. In most cases, in my life, when I was developing something, it was always connected with data. So even I was executing the function with the same arguments, it very often I get a different result because of this data has changed. The next thing is a local environment. It's better and better every day to run those kind of solution on our local environment, but still it is not so easy. Definitely you need to have connection to internet. It's very difficult to develop something on cloud when you don't have active connection to internet. When you are using Azure, it's all perfect when you have a Windows machine. When you have Linux or Mac operating system, it's getting a bit tricky. And the last thing is vendor locking. Everybody is saying that when you are developing application, especially when you are targeting to some specific cloud, we can be vendor locked. And this is the same with the function. This is a risk. And with the serverless. But together with that, if we will take this risk and we will try to be vendor locked by the technology, we can hit the market faster. Of course, we can build cloud agnostic solution, but in most cases, it means that we will need to have more time for development of that kinds of solution. So instead of getting locked by our environment, we can be locked by our competitors. So this is like a business decision for you and your customers. But I will say that the serverless approach, it is like a revolution for our life. Question to you, what are the biggest challenges when you are developing the system? Can you say some examples? Yeah, can be infrastructure. What's more? Great. And what about high performance? Scaling up? It's not a problem. So it depends. And I think when we are talking about the serverless, we should, I like to say to show the quote of Gojko Adzic. He is responsible for creation mind map and also cloud.js. And he said that many of the solutions that we consider best practice are solutions for the problems that no longer applies. When I was developing application, I always ask the question how many users there will be. What is the biggest user using application in concurrent way? How many data I should be able to handle in this application? But with serverless, those problems does not exist anymore. And when I working with new developers, I'm trying to change a bit a level more of mindset of them. So this is like 6 points that I'm trying to show them that they should think about software development in a bit different way. I think everybody that are developing maybe more than 5-10 years, I think 10 years is a good period of time, knows that it is very difficult to estimate the server. With the cloud, it's easier. And when I was young, when my boss said that I will need to provide estimation for high available solution, it was a huge challenge for me. And in most cases, when we wanted to figure out the correct architecture, correct estimation, that we overestimated to be sure that we will not make our solution not as good as it should be. And I think it was easier to convince my boss to buy a bit more expensive solution than invested enough money for another machine. With cloud, it's easier. But that time was perfect for doing architecture for optimized for this kind of reserved resource. But I had projects that so for example, some kind of startup was asking us for development that application that will handle a very huge traffic. They even didn't get to 10% of it, but they bought everything that they needed. They designed architecture for doing that. It was great. Everybody who was working on that was very happy because it cost money. Everybody was earning, not only the manufacturer, but also a software development company. But they didn't survive. And they have a huge cost at the beginning because the hardware, and then let's say the classic standard cost of the maintenance. But today, instead of building like that kind of super high power plant that can survive atomic war, we can bundle our solution from applications that are already existing on the market. Maybe we'll be not perfect from the beginning, but we'll give the value for our customer. Together with that, we was paying for reserved resources. So many times we have servers that was working for us and was doing nothing. They was waiting for the boom, for the Black Friday, Black Monday, Black something. And they was useful because they needed to handle this traffic, because when they wouldn't do that, we would lose our money. But in most cases, those servers was waiting. And now with service approach, we are paying only for the execution. We are paying for the traffic that really exists. If nobody is using our page, our solution, we are paying almost nothing. When there is a Black Friday, we are paying much more, but together with that, we are earning more money. Next point, optimizing for quick failover. I remember that I have a book, what I should do when something is happening with my server. And this book was, it should stop me from thinking. Like in the plane, when both engines are stopping, pilot should not try to figure out how to solve this problem. He needs to have the solution for it. So he opened the page, look for, okay, two engines are down, so reboot first one, reboot second one, check if it started, if not, start praying. And I have the same. I have the book in my desk that I should use when I run into troubles. Right now, when I'm developing, maybe not developing, when I'm designing application, I'm designing this application in that way that I'm optimizing the start time. Because the start time is almost near to zero, I can think that if something will break, our application will just run up again. And I don't need to care about this quick failover because my solution is already working with that, and it's easier. Then the next thing is replication of the production environment. One of my previous customers, when I asked him to prepare a solution, prepare another environment for the test team, he said it is not possible because I will need to pay £100,000 for this environment per year. For this customer, it was impossible to invest such kind of money for just test environment. And with serverless, we just copy our application and we are paying only for the real users. So if our testers are only testing 1 day per week, we'll pay only for the traffic, for the usage for this 1 day. And we can have as many versions of APIs, as many versions as functions as we want, because it costs us almost nothing. The next thing, we are perfect in building layer application. We are building database layer, business logic layer, UL layer. Sometimes we like to have sandwich with more layers than those three. And this is like a classic of our approach. But we should think about smart composition. Instead of building everything by our own, we should try to reuse somebody else's ideas. Maybe somebody else already developed something that we need. Maybe we can use it. Maybe it generates business value, and we can focus only on those things that can be really innovative, that can really bring the value for our customer. And last point, high versus low cost. When I think about classic approach, not even from the times before clouds, because sometimes when you are talking that we are moving to the cloud, we are just moving VMs to the cloud, and hooray, we are in the cloud. But truly, we have on-prem solution that is hosted by a cloud provider. We are in cloud, but we are not using potential of the cloud. And in most cases, those previous approaches was very costly. And with the cloud, when Microsoft was saying about the cloud, they said at the beginning, cloud is very cheap. Cloud is not very cheap. Cloud can be very cheap if you know what you are doing. And when you are trying to move something to the cloud, play with the price, play with the products. There are a lot of products in the cloud that are delivering the same value. And it is very easy to find similar product that will generate for you the same business value, the same feature, but the pricing model will be more optimistic for you. And so you can optimize the cost of the whole solution. If we think about readiness to going to the cloud, we should be a bit aware of some danger things. This is SLA. Oh, there is missing some beginning on the right side. This is SLA for the function. And we have two plans. The consumption plan, this is like a serverless. It means that we are paying for number of runs. Running function as a app service is a classic way. On the first point, you can see that there's 99.95% of SLA guarantee for you. But there is small gap. In this definition, there is of the time after trigger is successfully fired. And what is the SLA for the time before the trigger is fired? You need to look into details. It means that when you are, for example, if you are using Azure Functions for providing the backend, if the function environment will handle your requests, it will work correctly. If the request will not, and after this handling this request, it means that then we are counting SLA. Before that, before this trigger has been handled correctly, there is no SLA provided. So this is a small gap that you should know about that. And this is, you will not find this. You can, on the first point, you can see that this is very clear, but it's not so clear. And I promise you that I will show you what are the possibilities of usage the serverless in Azure. So we are having in Azure Function and Event Grid. Azure Function, this is a small piece of code that can be run by provider when we just follow the contract and can very easily scale up. Event Grid is like a very effective post office. It can handle 10 million messages per second. And in both cases, we are paying per usage. When you are thinking about Azure Functions, there is some typical scenario that we have time trigger. Every 15 minutes, our function is run. And for example, it can clean data. We can monitor blob storage. Then when function detects that something changed on the blob, it will run. For example, we can put the CSV file, and it can move the data to Power BI. Together with that, we can build the API on function. We can use this like a webhook. It works perfect. But my favorite scenario is Azure Function like a glue. This is something that can connect two services and integrate that. This is my project. I tried to reduce number of this yellow postfix card on my desk. So I built a paper display that is under the hood. There's Arduino that is connecting to Todoist by Azure Function. And writing the code that is integrating Arduino and Todoist take me just 15 minutes. And right now I have 3 of these devices. And the best thing, it costs me nothing for handling the traffic from those devices. Azure Function have some kind of free tier that you can use when you're starting with playing with that. I mentioned also about the event grid. So this is like a post office that can take some events from the event sources. Those event sources are being added every month, and and you can subscribe that. And this is very good service when you think about the performance. But there is one thing that we should know. Event Grid is trying to deliver every message in 24 hours. So when the message is not delivered, first time, they're trying to do the second, the third, and the fourth, and so on, in 24 hours. They are changing only the time how often they are pinging the subscriber. But after this 24 hours, when message will be not delivered, this product is not informing us that something happened with this message. So as far as I like this product because of this performance, there are of course it has some kind of filtering option. I not feel quite comfortable to using it because it's hard to get information what messages have not been delivered. I would like to have this built like a feature in this product. Then we have two other products. This is Logic Apps and Flow. This is something that maybe developers doesn't like at the beginning, because in these two products there are still serverless because we are paying for number of execution of it. We are building application from the blocks. So we have almost 200 connectors to different services like a Twitter, Facebook, Exchange, and many more. We can select the defined trigger that will run our defined workflow, and we are just putting those actions. This is perfect when you are building, for example, business, when we are trying to implement business rules in our application. It can speed up our development very good. And last product that I would like to mention is Cosmos database. This is something that it is not, this is something that is difficult to say that this is a serverless product, because in case of Cosmos database, we are still paying for the performance that can this product provide us. We are not paying for real usage. So we are paying for some kind of allocation. But it has so big performance for us that can handle the traffic and handle the all execution that are coming from our serverless applications. It can very easy scale up. It can be very easy move around the globe. Not only scaling up as when I'm thinking about the performance, but also scaling up when I'm thinking about geo-replication. But there is one minus of this product. It is really expensive when you are not knowing how to use it. And I mentioned that I will show you how we can shape our application from a real case scenario. So today I would like to show a very brief scenario. This is, let's think about somebody who is building a startup. And he needs to build a form that the customers will need to fill it. So we need to provide some kind of backend that will validate the data, store information about the customer, send thank you message to it, to customer, and because we are a startupper, we would like to get SMS that hooray, new customer has joined to our company. Maybe you think this is a very easy example, but I was developing application for one of the whiskey manufacturers, and they was saying some limited numbers of bottles. So we needed to provide for them application that the application lifetime was only 10 minutes, maybe sometimes 15. Because sometimes they are saying 10 bottles, sometimes they were saying selling about 1,000, sometimes 10,000 of them. And we needed to have solution that could survive very huge traffic in those small amount of the time. And building it in a classic way, it is of course possible, but it is not so easy to do. With Azure Function, when we warm up the solution, it was very easy to provide that kind of performance for our customers. And there was two great things. First of all, in most cases, we didn't pay anything for that because we was handling the traffic lower than this free number of runs that Azure Function environment is providing to us. The second thing, even if we was overcome this limit, for marketing division, it was very easy to count how much money cost every transaction, because we know how much money cost every function execution. And these points, in that solution, we of course needed to validate the data. We need to store information about the customer. We didn't send SMS to ourselves because the company was already big. We need to integrate with payment system and we need to send email. And when you're thinking about this approach, we can start from the prototype. So we can build one function that is handling the request, validating the data, saving the data to Azure table, sending an email, sending SMS, and giving response to us. This is great for the beginning. It will scale up as we want. But there are some small details that we should remember. If something happened with one of the parts, for example, when we'll be not able to save the data to the table, when we will not be able to send an email, we can run in the problems because we can lose those data. Azure function has limitation that they can run, one function can run 5 minutes. We can extend it to 10 minutes, but still, for example, when there is some problem with one of the services, our function can be just stopped by environment, and we'll be not able to do the next steps. But for the prototyping, that's great. You can do it. We can deliver that, and we can feel quite happy at the beginning. But maybe you would like to do something more sophisticated. So let's think about the solution that can be ready for the production. So this is just the starting point. So we will have the first function that will just handle the request. And when the function is handling the request, it's saving some information to the table that request has been handled, and putting information about this request to queue for next further processing, and returning to front-end customer response with information how they can check the status. And we need to provide the second function that will check the status when we will hit this URL and inform it is still being processing. Then we need to have next function that will validate the data. And if the data are not valid, when we are updating the status in those tables below, we are saying, okay, invalid data, we need, for example, email is not correct. And our customer that is hitting the function with request checking will get those information. And at this point, we can stop further processing. If data is correct, we are storing information that data are correct in those tables and putting information about the data to next queue. And it means that we can trust our environment that will process the data correctly in the future, and customer can already be informed that his data has been accepted. And then we have another function that are just finding out the request to another queues, and we are having separate function for saving data, sending email, sending SMS. So finally, the solution looks like this. Think about how many functions do we have here. 1, 2, 3, 4, 5, 6, 7. From one function, we move to 7th one. We have some queues between those functions. We think about deployment of this solution. It's not so easy like previous one, but with that kind of approach, we can feel quite safely. If we want to, for example, change Twilio to something else, we can just turn off the function. Our environment will still, our solution will be still working. We'll change Twilio to another provider. We'll run the function. This function will scale up to handle this traffic from this queue and send SMS or by using different provider. When something will happen with one of the services, and there will be an exception going from it, instead of losing the data and informing our customer that something happened with our environment, those data will be stored in poison collection. So as soon as we'll get information that something is wrong in our environment, then we can fix that and move the data again through this through our environment. But you can see it's a bit complicated. I mentioned that we have other product, that we have event grid. And with event grid, our application could look like this. So still we have the function on the left side on the top that is handling the request. Then on the below we have function that is checking the status. In the middle of this, we have event grid that is handling all messages that is sent to the solution. And the right side, we have function that is responsible for saving the data, sending email, and sending SMS. So when we are getting the request from the front end, we are storing information about this request. The red arrow means that this function, the left side function, is sending an event to event grid, and below this event grid we have the function that is validating it. It is subscribing to event that new data came to our system. When this function validates this data correctly, it's sending event to event grid that have the validation correct, these green arrows. And we have 3 other functions that are consuming those events, that are subscribed to those events. Look how our solution looks like now easier than previous one. With that approach, think how it is easy to add another service that will consume the data that are validated. We just need to add another subscriber to event that we defined before. But together with that, we should remember that there are limitations, that we can lose some kind of information when the message will be not delivered in 24 hours. Microsoft said that there is possibility to connect storage to event grid to save this information. I tried to do it, and I didn't manage. Probably I haven't invested as much time as I needed to do it, but I would like to have this feature built in the product. I talked with them about that, and they said, yeah, we know, everybody is telling this us. So I think that in future that they will include this feature in the product. And we have 4th solution. The 4th one is something called durable functions. Before September, before Ignat's session, I wouldn't show this approach, because before that the Azure function was not, Azure function 2.0 has not been marketed as generally available. And right now, instead of event grid, we can use some kind of orchestration function that will be sending the traffic between those functions. Still, we'll need to have the separate function for sending emails, sending SMS, or storing the data, and also validating. But instead of moving events around the system, we will have those logic that are sending events very nicely close in one function. There will be recipe, validate the data. If data is correct, send email, send SMS, store data. There is one minus using of this solution. This orchestrator is based on the function header, on the arguments that are passing to this function. It remembers the states, and it's basing on storage accounts. So you cannot play with the time. You cannot play with the header when you are moving the data around the system, because then this orchestrator function will treat this as a new run of this whole workflow. And also there's limitations that are strictly connected with storage account. With storage account, you have defined the throughput that is not so big. So on the one hand, it's allowing us to build the application by using only the code, not the components, like with the event grid. But together with that, we should remember about those limitations. And probably when you would be asking me to indicate the best approach for me, it would be very difficult to show you the one that is the best. It depends, as everything. When you're talking with technical architect, his favorite answer for the question is depends. And same here. For the prototype, I would indicate the first one, that you can very easily implement, very easily use in your solution. For my let's say, I don't like the names of the startup, but right now every project that you are doing over hours at home is a startup. For my project, I'm using the second approach, that I'm using queues to communicate between the functions. I'm thinking, should I move it to event grid or not? Why? Because when you are building functions that are communicating by queues, there is one minus of this solution. First of all, maybe not one, maybe two or three. When you are using queues, we are using storage account, and the storage account has some kind of limitation of the throughput. Together with that, when there's no huge traffic that is connected to our serverless environment, the storage account is being checked with a bigger amount of time between the checks. So the whole solution needs a bit amount of the time to speed up, to warm up. And I would like to have that kind of that kind of API, that kind of backend environment that could scale very, very fast. This solution will work perfect if it will have at least some kind of constant level of the traffic that will provide this possibility to sustain this number of checks for these queues. If I move to event grid, I will need to solve the problem with losing this information about the messages that will not be delivered to subscribers. But together with that, I will gain possibility to move these messages as fast as it is possible to the next function. And the fourth one, I would rather trust infrastructure than the code if you think about the product. So the rebel function is something good for me, but I would prefer going to event grid than that. And just summary. I hope that after today's session, you will know what the serverless means, how it can affect to you, how you can think about when you'll be developing new application. You should be aware of the main concept during that should be included when you are designing application, and you should know essential components essential serverless components that are available in Azure. Do you have some questions? Should I give some microphone? Okay, the guy that is sitting on the last row have the microphone the closest.
Hello, thank you for the presentation. My question is, you know, Azure Functions can be run longer than 10 minutes on consumption plan, and on Observers plan you don't have such benefits as scalability and cost effectively. And how do you handle this?
This 10 minutes, you need to design correctly. For some function, this 10 minutes is good enough. For some of them, it's not good enough, and you need to think about different solution. For example, I was talking sometimes ago, and the guy said that they're using Azure Function for sound compression. This making from phone calls, recording MP3 files. And they was checking the time of the, maybe not the time, the size of the WAV file. And it was, if the file was too big, they moved to processing to app service plan, but it was very, let's say, the basic level, and they have the separate environment that was running on the function, and the most traffic was going there. So it depends on your case.
Okay, thank you.
Hello, Michał. Thanks for these presentations. I would like to ask about the storage problem. Say, we talk about the serverless, we talk only about the execution, but what about the data? If we have understanding how to migrate the code versions, what about the data versions and data structure versions?
What do you mean about data structure?
Let's say if I have a new version of my app application, it will probably have slightly different tables in the database, slightly different data structure. So I will have to migrate not only my code, but also the data and the data structure.
Yeah, but this is, I think, the common problem for all application. And then when we have here the same approach, if we need to move migrate the data. It depends also on what database it stands. If we are using, for example, Cosmos database that we can change very easy the schema, this problem is almost does not exist. I know.
Yeah, I mean, you know, if there are some traditional mechanics for roll up of the new versions, then we know how to like update the database as well. But here it updates automatically. I mean, so what are the
but
controls?
This is you can use also the traditional one. If you are deploying new function, right now the function you are writing in Visual Studio, like the normal application, normal backend, and you can move, for example, this on the staging environment. You can have the second day. You can have database, and you can migrate the data and swap the instances. The approach is the same like in the classic development. The only difference is how we handle the traffic and how we handle the costs.
Okay, thank you.
Hello. I would like to ask what programming language. I would like to ask what programming languages can I use? Is it like Microsoft only, or can I run Python functions?
It depends. By default, it's supporting C#, JavaScript, and I think so F#. But there are some unofficial languages that are supported. Together with that, if you can compile your language to some kind of format that can be executed on Windows machine, it can be run as serverless. So in most cases, I can say that everything that can be compiled to some runnable exec or runnable file can be run as a function or as a serverless solution.
Okay,
that's why I was a big shot that this example with compression of the sound, I said, how we are doing, there's no support. Yeah, but we are running application from the function. I said, wow, I didn't think about that it's possible. No.
Okay. So anyway, if I can compile it into a normal Windows executable,
yeah, you can
probably with some interfaces to interface with this,
yeah,
then it will work.
It will work. And
That's
I think
cool.
the Python is supported in some kind of beta. I don't know all the languages that are supported.
Thank you.
Python, oh yeah, the Python is. Yeah, we have the second MVP in the room, so I have help there.
Hi, thank you for your presentation. I'm a little bit newbie in the serverless, so maybe it will be a newbie question. So as a developer, you said you want to focus on the business logic and coding.
Mm-hmm.
And of course, you need to figure out the problems that are in your code. And how do you, what is tooling in these serverless platforms to monitor, to logging, and for other features, because you didn't cover anything.
Yeah, this is like a
tooling.
beginning. We can organize a workshop sometimes in the future if you want. Just mail me and we can try to figure out. There are different layers how we can play with the code and check the code quality. Function are, I'm developer with C#. And those things that I will say, it will be similar to other languages. We can check the styling. We can check some kind of language errors by some kind of tooling, like for example, stylecop or fxcop in the C#. When you're thinking about the Java, there's just JSLint or something like that on the beginning level. Then we can use unit testing. So we can use the code that are used on the function. Then when we deploy it, we can use API test if everything is correct. Together with that, we can use integration test to check our whole application. Then we can connect, monitor, maybe by default function are being monitored, and this information about the errors are stored in a storage account that needs to be connected to functions. And together with that, you can also connect your own monitoring, for example, for monitoring library. And from the Azure, you can connect, for example, application insight. So it depends on level do you like to monitor.
The thing that I want to figure out is that are there any tooling to watch what is currently fails in your runtime? I mean, exactly, for example, distributed logging for collecting logs, and just to see in runtime that this is error and this is not. Or, for example,
You think about debugging application? Because
it's not real-time debugging, but you
can.
But the best source to figure out what is wrong is watching logs.
Okay, so you can use application insight, and when you connect multiple, not only the function, you can monitor with that whole solution, and you can get not only errors from the function, but you can see the whole chain of something that is happening on your application, and it is based on a real runtime. And so you'll get information that this function has been run, there was okay, there was an error, there is an exception.
This is inbuilt functionality.
Yeah, this is built in Azure's cloud functionality. This is the product that you can connect to.
So you need to make very granular functions, very small amounts, and you are paying for a rich small function invocation.
You are paying for number of invocation and also for time of processor and memory. So it's not so easy.
Okay, I see the balance between the granularity of this function
the best is
and
to write
responsibility.
The best way is to write as small function as possible, because then it is very easy to scale it up.
Thanks.